The next thing we want to look at is the concept of energy. The definition of energy in your textbook is that energy is the ability to do work. And later on, we'll define exactly what we mean by work, and that'll be in a later chapter. I'll just tell you that really what we mean by work is to exert a force through a distance. So if I exert a force on an object and I exert that force while pushing the object through a distance d, then the work is just equal to the force times the distance. But when I think about what energy is, I'd like to think of it more generally as if an object has energy, it has the ability to do something. Okay? So specifically, really what it does is work, but let's just say something and see how that works as we look at some of the different types of energy. So there are many different types of energy. One type of energy is called potential energy. And potential energy is energy that something has due to gravity. So for example, if you hold a pencil up and let go of it, you know what's going to happen. The pencil is going to fall. So in other words, when you're just holding that pencil above the ground, it must have energy because it has the ability to do something. In this case, it has the ability to fall. So potential energy is stored energy. In other words, it's there ready to go. If I let go of the pencil, then it's going to fall. Another type of energy is kinetic energy. Kinetic energy is the energy of motion. And we know that when an object is moving, it has energy, because after all, you wouldn't want to stand in front of a moving car, but standing in front of a car that's at rest is no problem. So something that's moving has the ability to do something like hit you, so it has energy. So kinetic energy is the energy of motion. Another type of energy is chemical energy. And chemical energy is another type of stored energy. And just to give you a couple examples of that, one example would be food. Food has chemical energy, so that when we eat that food, we take that energy and our bodies can use it to be able to do things. Another example would be gasoline. So gasoline has chemical energy, so that when we put it in our car can take that energy and convert it into kinetic energy. And that's one of the important things that we're going to talk about, that energy can be converted from one type to another. So our bodies and our cars take chemical energy and convert that into different types of energy. Another type of energy is electrical energy. And we're all familiar with electrical energy. That's what batteries provide, as well as what the wall outlets provide. Another type of energy is thermal energy, and that's the energy associated with heat. Then we have a couple more types. One type is nuclear energy. That is energy that's stored in the nucleus of an atom, and that's what's used in nuclear power plants. And, of course, it's also what's used in nuclear weapons. And then finally, the last type of energy we have is called electromagnetic energy. And as we're going to talk more about in just a minute, electromagnetic energy is energy that's carried by light. And it turns out it's not just light, but a number of related types of electromagnetic energy, one of them being X-rays. So electromagnetic energy is the energy that's carried by electromagnetic waves, and one example of that is light, and another is X-rays. So if you think about it, all of the energy that we have here on Earth ultimately Essentially, all of it ultimately came from the sun, and the way it got here was in the form of electromagnetic energy. So one of the things that I mentioned a minute ago is that energy can be transformed from one type to another, and also energy can be transferred from one object to another. And I want to just go through an example of this to kind of make that a little bit more concrete. So let's look at the example of my morning coffee. So the energy that I used to make my coffee this morning, ultimately that probably started out as coal. So here are a few lumps of coal. And the power company was nice enough to light that coal on fire for me. So in other words, it started out as chemical energy. And by lighting it on fire, a chemical reaction took place and released thermal energy. So we've already gone from chemical energy to thermal energy. What the power company does next is they take that thermal energy and they use it to boil water. So here's water, and what that does is it gives off steam. And that steam is coming off at high pressure. And so basically, if you think about what that is, it's just little water molecules, little H2O molecules, moving very fast. Well, that's kinetic energy. And what the power company does with that fast-moving steam is it uses it to turn a turbine. And a turbine is essentially a fancy word for a fan. So the energy from the steam is used to turn a fan, and that fan is connected to a generator. And what that generator does is it takes that kinetic energy and it turns it into electrical energy. And then that comes all the way over here to my coffee maker. And what my coffee maker does is it takes that electrical energy and turns it back into thermal energy. And there's where the heat comes from that boils the water that makes my coffee. And so there's my coffee. So that's a nice example of the fact that energy can be transferred from one object to another and can be transformed from one type into another. The next thing that I want to talk about is what we refer to as the mass-energy equivalence. It turns out that mass and energy are really kind of just two different aspects of the same thing. They are linked together. And you've probably heard of Einstein's famous equation before, even if you haven't known what it means, and that is that E is equal to mc squared. So E here just stands for energy. M stands for mass, and C stands for the speed of light. And by the way, the speed of light is the speed of all electromagnetic energy, and so that's also the speed of an X-ray. The only thing we really need to know about the speed of light at this point is that it's very fast. And so if you think about taking a number that's very big, like the speed of light, and squaring it, you get an even bigger number. And what that means is a little bit of mass can be converted into a lot of energy. And that's, in fact, what happens at a nuclear reactor. So in a nuclear power plant, basically what it's doing is it's converting little bits of mass to energy and giving off a tremendous amount of energy for a very small amount of mass. Now, other than in a nuclear reactor or in a nuclear bomb, we can't take mass and directly convert it to energy. But in those situations we can, and we look at that more generally and say that energy and mass are equivalent.